All right, next up we got Guy-Lussac's law. So this one relates pressure and temperature and assumes that volume is constant, or they just won't mention it at all. That's how you know to use this formula. So this one has a little more critical thinking and then one math problem at the bottom. Let's start with this one first. So the flask contains the same number of particles. All of these have the same number of particles. Which flask would have the highest pressure? So you see that they give you temperature information here. They give you temp. They're asking about pressure. You can go about this two ways. You can either know that if you increase the temperature, the relationship between temperature and pressure is directly proportional, meaning they will do the exact same thing. If temperature increases, pressure increases. If temperature decreases, pressure decreases. Or you can just remember that the hotter something gets, the crazier the particles are moving around. If it gets colder, the particles are like, but hotter, it's like, so those are the two ways that you could think of this. So if they want to know the one with the highest pressure, you need to have the one that has the highest temperature because they are directly proportional. The highest number here is this one, flask 4. Flask 4 has the highest temperature, therefore it has the highest pressure. All right, now we're going to get into the math. Sorry about that. Now we're going to get into the math problem. So my equation is P1 T1 equals P2 over T2. P1 over T1 is equal to P2 over T2. I have to find my variables. P1 T1, P2 T2. A gas is held at a pressure of 0.9 atm. So that sounds like an initial thing happening here. At 325 Kelvin. I love that it's in Kelvin. I don't have to convert to it. What is the pressure? So they're asking about P2 at 245 Kelvin. They even tell you in this problem that you assume that the volume is constant. That means that you do not need to include volume in your equation. So now you just have to plug in numbers. So P1 is 0.9 over T1 is 325 equal to P2 is unknown, that's what we're solving for, and T2 is 245. To solve this, you cross multiply, so 325 times P2 is equal to 0.9 times 245. Now we just have to do the math. So 0.9 times 245 is 220.5 equal to 325 P2. To get P2 by itself, we have to divide both sides by 325. So divided by 325, and that is equal to approximately 0.68. P2 is equal to 0.68. Because it is pressure and pressure is in atmospheres in this problem, our final answer is 0.68 atmospheres. All right, and last one for this law. Which flask has the highest pressure, and how do you know? So we already said that pressure and temperature are directly proportional. If I increase temperature, my pressure is going to increase. If I decrease temperature, my pressure is going to decrease. So again, they gave me some temperatures, but look, this one is in Celsius. They're trying to trick me. So I have to turn this one into Kelvin so I can compare it to the rest and see if it's bigger. So how I do that is degrees Celsius plus 273 is equal to Kelvin. Degrees Celsius is 126, so 126 plus 273 is equal to, now we just add these numbers, 126 plus 273, 399. So flask 4 is actually at 399 Kelvin. So the one that has the highest pressure by this logic has to have the highest temperature. The highest temperature is $3.99. So flask 4. Flask 4. How do I know? Well, I converted. I'm just going to like shorthand this. Converted to Kelvin. Compared the temperatures. Highest temp. The highest temperature means the highest pressure. And I know that because pressure and temperature have a direct relationship. And that is all for Guy-Lussac's law.